Well, the first concept is that, well, this is logarithmic form, and you many times you get asked to change it to an exponential form, and it's useful to know. Well, okay, this is logarithmic form. So in order to change it to an exponential form, is that you simply have to flip these two and get rid of a log because you find an exponent. So this becomes a to a power of 4 equals 16. And it's really simple. This is exponential form. And well, to go back, well, the same problem. We just, well, imagine it's not here. We just have to put the log first, and again flip this. So we're gonna have log a 16 equals 4. This is again logarithmic form. Okay, in order to solve this equation, you're gonna get asked to expand it. Well, to expand it, you have to follow some laws. First of all, if you have a fraction sign, it turns into a minus, and you're dividing, it's minus, and if you're multiplying with 3 times x squared, it's plus. So, well, in order to expand it, we have to put log 5 minus, because of the division sign, log again 3 plus, because you're multiplying, log x squared. Well, we have to put this in brackets because it's the same term, this term, and well, the only thing we're missing is, first of all, we have to distribute it. So minus log 3, distributed by 3 is minus log x squared. And the final step, if you have an exponent here, you can bring it to the beginning of the equation, and it's the same thing. And that's the last step to expand. So you end up with log 5 minus log 3 minus 2 log x. This is your final answer. In this equation, we are solving for x. Well, I'm going to read the equation. It's log base 3, parentheses, x plus 2, plus log base 3, 9 equals 3. So first, if we analyze the problem, we can see right away that log base 3, 9 can be simplified. Because 3 to the power of 2 is 9. So this, right away, we know that it's 2. So, well, it's 2. So, I'm going to write log base 3, x plus 2, plus 2 equals 3. Well, first we put the 2 to the other side, subtract 2 both sides. And so we end up with log base 3, x plus 2 equals 1. What we have to do now is get rid of the log. So to get rid of the log, we have to do the inverse. So we do 3, which is a base, to a power of all this. So now we can cancel out this. And well, what we do to one side, we have to do to the other. So we have to make also this base 3. So base 3 to the power of 1, which is what was here. So we end up with x plus 2 equals base 3 to a power of 1, which is 3. And we just have to subtract 2 again, and we get x equals 1. Okay, this problem is very similar to the last one. We're solving for x, but this time we're using a calculator. Okay, so we see a problem right off the bat. We can know that we have to add 2 to both sides to get rid of this 2, and divide by 3 to both sides. So well, basically, we end up with e to a power of x plus 3 is equal to 6 plus 2 is 8, divided by 3, 8 over 3. Over 3. Again, we have to get rid of the e, and as the law of logarithm says, we have to use the inverse to get rid of it, which is ln. Ln to a power of all this. So we can cancel now this, and we got rid of the e, and the ln is a base here. So we end up with x plus 3 equals ln 8 over 3. And well, we subtract 3 both sides, we end up with x equals ln 8 over 3 minus 3. And well, for the last part, we have to solve it using a calculator. And we put it in here, ln 8 over 3 minus 3 equals, okay, negative 2 0.019. That's the final answer. Okay, I'm going to explain trigonometry. Well, the two units of trigonometry, unit 1 and 2. And well, these are the two special triangles that we're going to use a lot throughout the unit. The 30, 60, 90 and the 45, 45, 90. The sides are 2 right equal 3 and 1. It's 1, 1 right equal 2. And well, that's it. Okay, first I'm going to review how to convert from degrees to radians and vice versa. So well, we're given 440 degrees, and if we want to turn it to radians, we simply have to multiply it by pi over 180. So 440 times pi over 180. Well, then it's 440 pi over 180. So simplifying it, well, we can take away the zeros, and 44 over 18 can be 22 over 9, 22 pi over 9. And that's the final answer, because it's with our calculator. These are the radians. And we're going to do it backwards from radians to degrees. We have to multiply by 180 over pi. And well, the answer here is 3 times 180, which is 540 pi over 10 pi. And we'll, since there are both pi's, we can cancel them out. And we end up with 54 degrees, because we can also cancel out the zeros. 54 degrees. Okay. And it's helpful to find coterminal angles. And coterminal angles are angles that look exactly the same in the plane, but are not really the same. For example, you have 143 degrees. To find two coterminal angles, you add 360 and subtract 360. It's going to be the same. So for example, 143 degrees should be around here. And well, if it's here, you add 360 from here, logically you end up in the same place. Well, if you subtract, you will as well. And well, with the radians, the same. This is negative pi over 3, so it's negative 60 degrees, so it should be around here. And it's the same thing. Well, since we're talking about radians, we're going to add 2 pi and subtract 2 pi, and we should get the two coterminal angles. A very important part of this unit is the 6 trigonometric functions. And well, we have sine, cos, and tan. And well, SOHCAHTOA, for example, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And well, these ones are just flipped. So cosecant is sine backwards, secant is cosine backwards, and cotangent is tan backwards.